So this question involves a right angle triangle, and it's given as a length, and it's working with an angle in the triangle, apart from the right angle. So it's got another angle, and any angle we tend to call theta as any angle. Right angle triangles with angles and lengths, it's shouting out trigonometry. So in other words, we need to use one of the trigonometric ratios. And one of the ways that we think about this is we think about a standard right angle triangle with an angle theta, and we think of the saying, silly old Harry caught a herring trawling off Aberdeen. So car toa, silly old Harry caught a herring trawling off Aberdeen, some way to remember it. And of course then we label the triangle. So because theta's here, the angle we're working with, then this must be the opposite side, this must be the adjacent side next to the angle, and this must be the hypotenuse. The right angle points to the hypotenuse. So longest side, hypotenuse. The sine of theta, follow the letters, O over H. The cosine of theta is going to be A over H. And the T is for tangent, O over A. So the opposite length over the adjacent length. That's what you should be writing down every time you see that it's a right angle triangle involving angles and lengths, either to find the angle knowing two lengths or to find a length knowing an angle and a length. Then you know it's going to be trigonometry, and you should be writing this down as a starting point to remind you what you're going to be doing for this question. So the first thing we're going to do is label this question up with the side lengths letters. So we're going to be using opposite, hypotenuse and adjacent. Here's the angle the question's given us, so this must be the opposite side. This is the hypotenuse because the right angle is pointing to it, so that's going to be the hypotenuse, the longest side. This length is next to the angle, so that's going to be the adjacent side. Adjacent means next to. We go through the SOHCAHTOA process to try and decide which of the ratios is going to work for us in this question, and we can see what information they've given us. They've given us the value of A, so we can tick under A. That automatically tells us we can't use the sine. We don't have any information to do the sine rule, or the sine function, sorry. So we look at what else we've got. Well, the question says it wants the length of BC. So in other words, we want to find out this length here. So we have to use the letter O in our workings, otherwise we can't get the length of BC. Well, that means we can tick under O. We've already discounted that because we don't know H. Therefore, we're going to be using the TOA function. So we write out that rule in full. So tan theta is equal to O over A. Fill in the numbers that we know for the question. Well, they told us the angle was 36 degrees. The question told us the length of A was 8.7. But we don't know the O length. We need the O length, so that means we've got to rearrange this rule here to get O on its own. So that means the 8.7 has got to come across here. This symbol means divide part of, out of. So therefore the opposite of dividing is timesing. So we're going to times by 8.7 to get the O on its own. So the O length is going to equal 8.7 times the tan of 36 degrees. So again, calculator paper. We've got to make sure our calculator has either the word deg or the letter D in our screen, which is short for degrees. We can see on this calculator that it's actually got the word rad. So it's trying to work in radians. So the first thing we've got to do is make sure our calculator's got the word deg or the letter D in the screen to make sure we're working with degrees. Just type in the calculator then what you've got. So 8.7 times, press the tan key, 36 degrees equals 6.3209. So equals 6.3209. Before we write the answer line, then we must look at what the question wanted. It wanted the answer to three significant figures. So 1, 2, 3. Always count from the first non-zero digit. So 1, 2, 3. So that means we're going to cut the number there. The 0 is less than 5, so this stays the same. It's not halfway up to 3. So the answer here will be 6.32. So that's an example of how to solve a problem involving a right angle triangle and the trigonometric ratios. Remember your SOHCAHTOA? Silly old Harry caught a herring trawling off Aberdeen. Go through the process of identifying the information you know and the information you want. Once you've got the ratio that you need to use, write it out in full, fill in the missing numbers, decide how you can rearrange it to get the letter you need on its own, and then put the numbers in the calculator and round to the answer accuracy they wanted.